Another way to look at the variability of normal feature selection can be looked at from this chart. So you can see that, for example, what is the most important feature in one of our data set? You'll find that, for example, the top feature was ranked top, let's say 35% of the time, but it is ranked second, also about 35% of the time, and the third, it is ranked third 20% of the time. So, when you say what is the most important predictor for your machine learning algorithm, there's no simple answer, because the most important feature is varies. And if you look at the one that is picked as the most important feature, it was ranked as the most important only 35% of the time. The rest, another 35% of the time, is ranked the second most, and the third, and an additional 20% of the time is ranked as the third most important feature. And then for some of the runs, they are ranked even lower. So that's very disappointing, generally speaking. Okay, so as Dennis has suggested, one way of reducing this instability is to average over many iterations at different level of the algorithm. You can increase the number of permutation in MDA, increase the number of sampling in Lime, and increase the number of permutation in Sharp, so on and so forth. That takes a lot of computation, as I said. The second way is what we described in our newest paper, cluster-based feature selection. That paper was inspired by the cluster MDA that Dr. Lopez de Prado has described in his latest book. So the cluster-based feature selection is not our invention. However, the clustering effort, the clustering method that was described in Dr. Lopez de Prado's book is k-means, and we find that to be not as good as hierarchical clustering. And then that's what we implemented on our platform as well.